Okay, so in this section, we're going to talk about derivative of trigonometric function. So the derivative of trigonometric function. Okay. As we know, there are six types, six different ratios, or six different trigonometric functions. The first one is sine x, then the second one is cosine x, and then you also have tangent x, and then 1 over tangent x is cotangent x, and then we also have secant x and also cosecant x. Let's see the derivative for it. The derivative for sine x is cos x, and then the derivative of cos x is negative sine x, while the derivative of tangent x is secant square x, while the derivative of cotan x is negative cosecant square x. So like if you see here, actually there is a pattern. Like if it is tan, then it will be secant square. But if it is cotan, it will be cosecant square. So it means like it can easily be memorized just by looking at here the prefix. And then if the derivative for secant will be secant x times tangent x, while the derivative of cosecant x will be negative cosecant x and also cotangent x. When you see this also has a pattern, right? If there's a second for the co part, it will be the cosecant and tangent will be cotangent. And then for every time you have the co part, like cosinus and then cotangent and then cosecant, you will have negative value. So you see the pattern here. Now let's take a look at page 8. On page 8, we have several examples here. We're gonna try to do the first derivative of x squared sine x, right? And in this case, I will see this as product rule, right? This one is u, well, this one is v, okay? And according to the product rule, the first derivative of y will be u prime v plus u v prime, right? So we're gonna apply this one. U prime is 2x, v is sine x plus u, which is need to copy this, and v prime is cos x. And this is it, just like this. And next for number 2, we also have y equal to, in this case, we're gonna apply so-called chain rule. Why we do apply chain rule here? Because what we memorize is just sine x, right? Or I just write it with green colors, like sine x. But what we have right now is sine a certain function of x, right? So then we're gonna let this as x first, or we're gonna say that okay, this one is kind of just sine x. We're gonna treat this like sine x. So then the y prime will be just simply cos that green part, right? The sine green, it will be the cos green. So I will just put this as green as well. So then this will be 2x squared plus 3x, right? Because it is not x, then what you do next, you have to do so-called chain rule, right? So you have to multiply this by the derivative of this function. So then the derivative of this function will be 4x plus 3. And then I suggest you to put the 4x plus 3 in front so that you will not multiply this because it shouldn't be multiplied with this. And this will be 4x plus 3 times the cos of 2x squared plus 3x. Now let's take a look from page 9. We're gonna have another two example for page 9. So on page 9, we have here the first number is y equals sine x over by, what is that, sine x plus cos x. So I can see this as quotient rule, right? Because they are the fraction and then in which you have all in the function of x, right? So then the y prime will be just simply u prime v minus u v prime over by v squared. So then the u prime will be the derivative of sine x, which is cos x, while the v I just need to copy, don't forget the bracket, right? And then negative here, u is sine x, and then the v prime will be cos x minus sine x, right? Just make sure that you memorize before. And then v here is sine x plus cos x the square. Then we can expand this, and this will be cos x sine x plus this one. Just write it in black color, like cos square x minus sine x and cos x, or plus sine square x, right? And okay, hold on, like before you eliminate that, this will be sine square x plus 2 sine x cos x plus cos square x, right? So what we have right now, we can cancel this term because they're the same. And then for this one, it is one of the identity. Cos square x plus sine square x will be just 1. And the same thing with this will be just 1. Well, I'm going to convert this to be sine of the double angle. So it's just sine 2x. So then it will be 1 plus sine 2x. So this is going to be our derivative. Now let's move to number 2. In number 2, we have y equals cube root of cos square 3x minus x cubed. So in this case, it's quite complicated, right? And I think this is gonna be a bit complex. Why? Because it consists of 2 layers of chain rule. What does it mean with 2 layers here? When you see here, actually we have to take a look this as a green function, like a certain function that we don't want to see now, to the power of 1/3, which is the cube root, right? So then it just simply will be, and you know, like the green one here is the cos square, sorry, just the cos 3x minus x. What we have here, x cubed. So the derivative of this, okay, just let's try to assume that this one is x, right? X to the power of 1/3, or just the green part to the power of 1/3. So then the derivative will be just 1/3 times the green part, right? And I will just, okay, just forget this one. This is just the green part, right? It's just the green part to the power of negative 2/3. And then because this is not exactly x, right? We're gonna do the chain rule. So we're gonna times it with the derivative of the green area here. But the thing is, when we try to convert this, right, we also don't know this, right? What we are able to do is the derivative of cos x. Okay, then, so we're gonna have another layer of zero in the future, right? In the near future. So the cos of red one, we're gonna derivative the green area first. So then this will be negative sine the red area, which is, let me put it as the red area first, which is 3x minus x cubed. Okay, and then because this one, we still have something that we define as another variable like x or other things. So then we have to times it with the derivative of the red area. So then this red area will be 3 minus 3x squared. Okay, and then let's rearrange this, and I think we can cancel this part, like 3, 3, 3 here, and become 1. So then we can conclude that the derivative of this will be the red one is, I'm gonna join them with the negative part, so like negative 1 minus x squared times with the green one, which is sine 3x minus x cubed, and over by, why over by? Because we have negative index here, over by cos square of 3x minus x cubed. This is the cube root, right? So then the answer for number 2 is like this. Okay, we use so-called chain rule, and in this case we have double, right? We green area, and we also define the red area in the general. Now I'm going to pick like random questions that I think it's a bit tricky, or we have a trick to do this. So let's take a look still on the same page 9. So let's take a look page 9, 1F. We have so-called y equal to 1 plus tangent x over by 1 minus tangent x. So the way we differentiate this one is by firstly we define this, we try to refine this form to be another form. Like the one here, I'm going to change it to be tangent pi over 4 plus tangent x, the same things, and 1 also the same things, and then I'm also adding tangent pi, pi over 4 times tangent x, which is tangent pi over 4 is just 1, so it doesn't really affect the tangent x and doesn't really affect the whole questions, right? But this form is very unique because it's actually the addition angle of tangent. So it becomes tangent pi over 4 plus the x. So then when you try to differentiate this one, it will be even simpler, very, very much simpler. So then this will be simply second square, right, of the something that we have here, green, which is pi over 4 plus x. And then we have to times it with the derivative of the green one, which is only 1, so it doesn't affect anything. Then it will be just the same thing, right? It seems like we don't multiply with any derivative of this, but actually the derivative of this is just 1, so it's invincible. Okay. Now let's go on to part, let's say 1m. So we have 1m, y equals second pi over 2 plus x over by the cosecant square of pi minus x. So in this case, I try to simplify this. I don't want to have pi over 2 and pi here because actually we can change this, right? And remember, we have fourth quadrant. This one is pi over 2, and this one is 3 pi over 2, right? And then the horizontal one is pi and also 2 pi, or 0, right? So in this case, what we have for the numerator is pi over 2 plus something. So meaning that it is located, let me use this color, it is located here in the second quadrant, right? In the second, first and the second quadrant. And when you take a look the second only positive here and also here, right? So then in this case, we're gonna change this to be a negative value. The negative ratio of, because we use the vertical line here pi over 2, so then we're gonna change the ratio to be cosecant. So this is gonna be changed to be cosecant, and the angle will be just x. Then over pi, let's take a look at cosecant, yeah? Pi minus something, so meaning that the same quadrant, right? Pi minus something. So this one is pi over 2 plus something. So then the cosecant here definitely good because cosecant here is positive. And then because we use the horizontal one, which is 5, so the ratio will not be changed. So then it's just simply the same thing, which is just cosecant x, right? Because we have square here, it will be square. See here, now we can simplify it again, right? So then it becomes what? Negative 1 over cosecant x. And you know cosecant x is 1 over sine. So then this will be just negative sine x. And the derivative of negative sine x is just simply negative cos x. Okay, so that's it, right? You just need to modify first the questions, and then you can just simply differentiate the function. Okay, let's go on to page 10. I'm going to emphasize three numbers here. Like the first number is number 4. So let's take a look here. If you have y equal to 3 over 8x plus half sine x plus 1 over 16 sine 2x. Show that, you have to show that, or you have to kind of prove that the y prime is just cos or half x. So if you're doing this kind of thing, you have to show something like the first derivative will be like this. The first or the major guidance for us is only the angle, I think. Yeah. The first guidance is the angle, and the second will be the ratio of this. But just forget about the ratio first. You just focus on the angle. When you see here, the angle here in the questions, like the function, right? The function of y here is just x and 2x. Well, our goal, we want to show that the angle changed to be half x. So meaning that later on we're gonna utilize so-called double angle, right? So then we're gonna change this to be half of this angle so that it becomes half x. Well, this one we're gonna change it twice, right? Half of that angle become x and then another half of that angle so it becomes half x. Okay, but we don't do it now. Why? Because when you change it right now, like sine x, it will be just simply 2 sine half x cos x, right? But this one, if you try to differentiate, then this will be product rule, which is more complicated. So we want to avoid a complicated derivative. So then we just do the derivative first, and then we're gonna convert the angle later. So that's a strategy. So the y prime will be just simply 3 over 8, and then plus, what is this? Half cos x, and this one will be 1 over 16, right? But times with this later on, like 1 over 16, and this will be cos of that particular something, right? And this something is just 2x. Then we times it with the derivative of that is 2, right? And I can cancel this to be 8. So then let me refine first. So this will be just simply 1 over 8 cos 2x. And now it's the time for us to change this to be half of it, right? And because this one is cos, and I want to recall about the cos double angle, so when you have cos 2 alpha, then this will be equals to, can be 2 cos square alpha minus 1, or also can be 1 minus 2 sine square alpha, or also well, someone say, or you also can say that it is just cos square alpha minus sine square alpha, right? But in this case, again, the guidance is the x, and it's good to go because of the double angle properties here. We can change it to be half of it, right? And you also have to do care about the ratio. So what you want here from the cos, you want it to be just cos. So then you can just choose this one. Okay. So then we're gonna convert it accordingly to the properties. This one is cos x, so this will be 2 in the bracket cos square half x minus 1. So by doing so, you have half x now. Okay, so good to go. Next, plus 1 over 8 cos this thing, which is, it will be 2 cos square. This one is as x because the double angle here is 2x, so the half of it will be x minus by 1. This, and then I try just to expand all of this. So then this will be cos square half x minus half. Well, this one will be 1 over 4 cos square x minus 1 over 8. And then I try to simplify this, right? I can calculate this 3 over 8 minus 1 over 8. It will be just simply 2 over 8, which is 1/4. And then I have minus half. I'm going to put it here. And I'm going to keep this one because I couldn't calculate it. Well, for this one, what I have to do, I have to do converting again the x to be half. So I'm going to utilize the same thing, but now I have the square. Just put the square later, like here outside, right? Well, here is the cos x, and I will convert the cos x to be 2 cos square of half x minus 1. After you do that, and then this become minus 1/4. Hopefully it's okay, good to go. Plus cos square half x plus 1/4, and then gonna expand the square first, so this will be 4 cos 4, sorry, cos to the 4 of half x minus 4 cos square half x plus 1. So when you see here, we can just eliminate some part. For example, like this one, we can eliminate with plus 1/4 times 1, which is also 1/4. And then you also can see here cos square half x can be cancelled with this one, negative cos square half x. So then the remaining is just cos to the 4 of half x. So then you can prove it. Now go on to number 5. In number 5, we also try to prove, what we have here is y equals 4 cos square x plus pi over 4 minus 2 over by sine x and cos x, right? And then show that the y prime minus y equals 4. Now let's see, Again, the guidance for us is the angle. And you see, let's compare the angle of this, the angle of this, and the angle of this, right? Well, they don't show any angle here, so we just focus on this angle. When you see here, this is pi over 4, it's kind of disturbing, right? Like, it will be better if we can just convert this ratio to be just cos x or sin x or any other ratio with the angle of just x without any plus pi over 4, right? But the thing is, we cannot do anything with 2 pi over 4. What we can do is something with pi over 2 here or with pi, right? And let's imagine if we double this pi over 4, like pi over 4 times 2, then it becomes pi over 2, right? Which is something that is desirable for us. So then we can convert this to be something with x only, right? So then we think of, okay, maybe this is the part of double angle, right? And let's recall the same thing when we have cos to the 2 alpha equals to cos square alpha minus 1. It seems like they have pretty much the same form. Well, I'm vectorizing the 2 from these two terms. That will be just simply 2 cos square x plus pi over 4 minus 1. Boom, you see, it has the same, how to say, it has the same form, right? 2 cos square something minus 1. And we hope this angle, which is alpha here, change to be 2 alpha, which is a double 1. So it's good to go. And we see the pattern now. We see what the author want to do. So let's just do it. Like this will be cos 2 alpha. So this will be twice of it. So this will be 2x plus pi over 2 over by so-called sine x cos x. And let's see again about the angle later. This cos pi over 2 plus something, meaning that in this quadrant, like the second. So then the value of cos will be negative value, right? So then this will be just negative 2. And because we use the vertical one, so then the cos will be changed to be sine of 2x. Okay. Again, we are driven by the angle. When you see now the angle, it seems like they are different now. It is 2x and x, right? So we have to think a way to simplify this to make it to be the same angle. And we also can recall the double angle of sine 2 alpha, which is equivalent to 2 sine alpha cos alpha. So then if I have sine x and cos x here, then I can just move the 2 here to be half sine 2x, right? So then I'm going to convert this to be half sine 2x. Boom, you see? The same thing. Then it will be negative 4. Then the y prime will be just 0. So then by knowing this, we can show that y prime minus y is just equivalent to 0 minus negative 4, which is also 4. Then we can show this. And then now let's go on to number 7. In number 7, we have y equal to x plus 1 over a times cotangent of x minus by 1 over a cosecant of ax. And we have to show that the y prime equal to 1 over 1 plus secant ax. Okay, like this. Now, firstly, we believe that we are driven by the angle. And the angle here is ax. And the goal of our angle also ax. So meaning that we don't need to do care about the angle, like we don't need to change the angle, it's already good enough, right? So we just directly differentiate it. This will be 1, while this will be cotangent, so it will be negative, I'm going to put negative here. Negative 1 over a cosecant square of that something which is 2x, and we have to times it with the derivative of this. Sorry, this one is not 2x. This one is ax, and times the derivative of ax, which is just a, right? So then I can just cancel this. Minus by half times with the derivative of cosecant ax, which is negative cosecant something, which is the ax, times with cotangent of something, which is the ax. Why I always write 2. And then it's not finished yet because we have to times it with the derivative of the green area, which is a. By doing that, we can cancel the a, and let's simplify this. This will be 1 minus cosecant square ax plus cosecant ax times cotangent ax, right? And then from here, perhaps we're done, but we don't have the same shape, right? We don't have the same form. So then let's take a look at the form. And in this case, we always set this as our guidance. This is our goal. We have to go to this goal and kind of try to make it to have the same form like this. And now what we have here in the goal is the form of the fraction. But what we have right now, we don't have any fraction yet, right? So then we're going to convert this to be fraction. As you know, cosecant is 1 over sine. So then this will be 1 over sine square ax. And cosecant here is 1 over sine ax. Cotangent is cos ax over by sine ax. So it seems like the denominator all is sine square ax. So then we can just combine them together. Why we combine them together? Because you see, the goal only have one fraction. But how many fractions that we have? We have 1, 2, and 3, right? So we have to combine this according to the goal that we want. So then this becomes sine square of ax, and it's just negative 1. Well, this one is positive cos ax. Okay? And then again, we take a look from the goal that we have. Okay, it seems like we have the fraction now, but the thing is, you see, the denominator is in the form of addition. Well, what we have, we only have 1/3, right? So we have to think the way how to convert the denominator to be an addition, or at least addition or subtraction first. It's not like multiplication, okay? So then we're gonna utilize the identity of sine square ax, which is it's equivalent to 1 minus cos square ax, right? And in this case, we can see here that, oh, we can express this as like a square minus b square, which is, it will be a minus b times a plus b, right? So then the denominator, I can convert it to be 1 minus cos ax times 1 plus cos ax. I think it's quite good because now what we have the addition term here, which is this one also addition, even though the ratio is still not the same, right? And meaning that we have to think the way how to remove this, because what we need in the denominator only one type of addition. We don't need this term, right? So meaning that we can cancel this if we can convert the numerator to be 1 minus cos ax. You see? Cos ax. So like the cos ax. So then the sine square here, you have to change it to be cos. So then this will be 1 minus cos square ax according to the identity minus 1 plus cos ax over by 1 minus cos ax times 1 plus cos ax. Okay, then I can just cancel this, and then you see what happened here. If I wait, let me see. If I vectorize the cos ax, so then what I will get here is negative cos ax plus 1, which is exactly equivalent to 1 minus cos ax. So I times it with 1 plus cos ax here, so then I just cancel this term. So you see, now we're getting closer to the goal. What we have now is cos ax over by 1 plus cos ax, right? It's kind of similar now, but the thing is, you see, the numerator is 1, right? What numerator that we have cos ax. How to convert cos ax to be 1? It's just simply, we just divide it, right? So the next step, we're gonna divide this. So it's not out of the box thing, you just think based on the guidance from the goal. You have to reflect
like you have to check all the time from the goal. If the goal is 1, then you have to think the way how to make it to be 1. If the goal is addition, you have to think the way how to make it to be addition. Okay? By doing so, the numerator now becomes 1. And you see what happened to the denominator? 1 over cos ax, it will be second ax. While cos ax over cos x, it becomes just 1. So then we have exactly the same thing like the goal. Okay? So every time you stick to the goal, right, you're gonna get it. Every time you stick to the goal, you're gonna get it. And you see, our guidance always be the angle and also the ratio types. Okay, I think I have one more number here. Number 8. Y equal to sine x over by 1 plus cos x. Okay, in this case, we have to show that y prime is equal to half secant square x over 2. So when you see here, like, okay, I have x here, right? I have x here, but what you have here is the half of it. So definitely we're gonna apply the double rule, the double angle rule. Like sine to alpha, you convert it to be 2 sine alpha cos alpha. And then cos to alpha, you can convert it to be either 2 cos square alpha minus 1 or 1 minus 2 sine square alpha, or just cos square alpha minus sin square alpha. It depends on the ratio of the other, let's see. Yeah. Sin x it becomes 2 sine half x, or just x over, to make it the same form like the goal that we have, and then cos x over 2, and over by 1 plus cos x, or okay, wait, okay, when you see here 1 plus cos x. So it's the same thing, like it's when I move this term to the left side, so then this will be just simply cos 2 alpha plus 1 equals to cos 2 cos square alpha, right? So you can convert this addition to be just 2 cos square of the half of the angle. So then this will be just 2 cos square of the x over 2. So you see here we can cancel just one part, which is the cos x over 2. And the remaining part is just simply what? It's just simply tangent x over 2. So then when we try to differentiate this, it's just simply secant square something here, right? Times it with the derivative of half x, which is just half. So then we can prove that it is half times secant square x over 2. It's very easy.